Hello! In this video I show you how I go about repairing a central heating pump that appears to be broken and will not run. Now the pump I'm going to repair is in a Vaillant combination boiler, and they've got F75 come up on the display and the boiler is no longer working. But this fix applies to all central heating pumps, so it doesn't matter whether your pump is in a boiler of any brand or whether you have a traditional system where you have a pump on its own. This could be a really easy fix to get your heating back up and running again. Now this homeowner has a Vaillant combination boiler and it's got F75 in the display. Now I want to let you know that F75 can come up for several different reasons. It could be a faulty pressure sensor, it could be that the pump actually needs to be replaced, it could be expansion vessel. And of course, I've made videos all about all those different faults and how I go about replacing them. And you can find a playlist in the cards above now, or you can find the individual videos in the description below, along with lots of other links to really useful help videos. So if you are getting F75 on your display, of course, I recommend that you watch those videos first so you can find the correct faults on your boiler. Now in this repair I'm going to be replacing the capacitor which is inside the pump. Now this capacitor has a whole load of numbers on it, and at the end of the video I'll explain to you which of these numbers are important, so make sure you stick around for that. Now you find capacitors on lots of electric motors these days. They're sometimes called motor runs. Now this one here, this is a large one. This comes out of a hot tub motor, and this one comes out of a washing machine motor. So if you've got a faulty motor, then it may just be that all you need to do is to replace the capacitor and then the motor would start working again. So this video may help you if you've got that faulty motor. One last important point: to get to the pump I need to remove the cover of the boiler. When I remove the cover, that will affect combustion of the gas in the main heat exchanger. Because of this, only gas registered engineers should be removing the covers of boilers. In the description below I've left links to the gas register where you can find a gas registered engineer in the UK. But if your central heating pump is not inside the combustion area of your boiler, so it's external, then you don't need to be gas registered to carry out this repair. Right, now let's get on with fixing this pump and getting it running again. Now here's my customer's boiler and it has F75 on the display. Now this is the exact sequence which I went through to determine that the capacitor on the pump was faulty. And we're 2 years on from that now, and the boiler is still running absolutely fine with that new capacitor in the pump. Now the first thing which I did was to reset the boiler. So the boiler is now reset. I've got the central heating radiator in the display. So the boiler is trying to run and bring on the central heating. You can see the pump coming up in the bottom right hand corner, indicating that the boiler is trying to run the pump. And the boiler is looking for an increase in pressure on its internal pressure sensor. Because when your pump runs, it increases the pressure in the boiler. The pressure sensor reads that pressure increase. It tells the circuit board that the pump is running because it sees an increase in pressure, and then the circuit board will then go on to its next sequence, which will be opening the gas valve and firing up the boiler. If the circuit board does not see an increase in pressure on the pressure sensor when it tries to run the pump, it will then try running the pump 5 times before it will then lock out with F75 on the display. Now I can see the pump in the bottom right hand corner of the display showing that the pump is trying to run, and this is the 4th attempt of the boiler trying to run the pump and looking for that increase in pressure. So now it's going to run the pump for a 5th time, and there we go. We can see the radiator symbol there indicating the heating is on, and our pump symbol just there indicating that it's trying to run the pump and it's looking for that increase in pressure. And there we go, F75 has now come up on the display. So the boiler has locked out again because the pump is not running. Now reset the boiler, so the boiler is going to try doing exactly the same thing again. I can press the minus button, which will show me exactly how much pressure is in the boiler. So it says 1.6 bar. On the new Vaillant boilers, we need to press a button to light the display up. Then we press the button underneath the radiator symbol, and then we press it again, and then we can see exactly how much pressure is in the boiler. When the pump runs, I expect to see that pressure increase between 0.1 and 0.4 of a bar. If that reading doesn't change, the boiler will lock out with F75. Now whilst the boiler was going through its startup sequence, I was carefully listening to the boiler and I was listening for the pump running. So that would be like a humming sound. So every time the pump comes on, I'm listening to hear an additional humming sound of the pump running. And I couldn't hear any humming, so that's what made me think straight away that the pump is not running. So now I'm removing the front cover of the boiler, so I undo the large screw in the middle of the boiler. I don't have to take it out. Then I just release the 2 clips on either side and I can lift the cover away, like that. Some of the Vaillant boilers don't have this large screw in the middle. They have a screw on each side and the cover just lifts off in the same way. So now I'm going to fold the front cover down, and again I'm listening for the pump running. Now this is the pump here, and I'm just holding it to see if I can feel the pump running. So see if there's any kind of vibration indicating that the pump is running. So I now check to make sure that the pump is in the display, so it's definitely just come on. So I should now be able to hear it and feel it running. So now I can't hear the pump running and I can't feel any kind of vibration to indicate that it is running. So the next thing I'm going to do is to physically check it. So I'm going to undo this large screw on the back of the pump. Now I'm always very careful when I do this because I might get scalding water come squirting out, and it might actually be quite a flow coming out of it. Now I'll reset the boiler again. I'm going to put the boiler into a service mode by pressing the plus and minus buttons together. That's just going to bring the boiler on and keep the boiler running. There we are. So now it's trying to run the pump. You can see that the pump symbol is in the display. And now I'm looking to see if the shaft of the pump is actually spinning. So I use a screwdriver and I put it into the pump, and I'll see if the shaft of the pump is rotating. So at the moment the pump is not running. I'm putting my screwdriver onto the end of the shaft of the motor, and I can feel that it spins very freely. So that's a good thing. But it's definitely not running. You can see there's a large arrow on the back of the pump indicating the direction in which the pump should run, which in this case is anti-clockwise. Now here's a pump that I replaced recently, and you can see how easy the shaft spins, but that's with no water in the boiler. Now I try flicking the shaft in the direction it should be running. So I give the shaft a bit more of a spin, and there we go, the pump is now running. Gas valve opens and boiler fires up. I just wanted to point out to you that the sound that you can hear now isn't the pump running. The pump is actually really quiet. The noise that you can actually hear is the fan running and the burner operating. So the flame is on, and both of these are quite noisy. So when I stop the pump in just a moment, the fan and the burner continue to operate, but the pump is stopped. If I try put my screwdriver onto the shaft now, you hear it rattling away because the shaft is spinning. I try stopping the shaft just to see how powerful the pump actually is. It feels pretty good, but I have managed to stop it. But another little flick and it's running again. Now you can see the flame is in the display, but now I'm going to cancel that service mode. So now I'm going to repeat the process and check it all over again. So I'll reset the boiler. So now I'm going to put it back in the service mode, but I could do this just as easy by putting central heating on or by running a hot water tap. But I want to make sure that the pump is being told to run all the time. I can see it's not running again. Give it a little flick with my screwdriver and it starts pretty easily. And there we go, we can hear that noise indicating that it's running absolutely fine. And now I just replace the pump cap and just do that up. And there we go, that's all done now. Now I just use my water vacuum and suck up all the water that's been pouring out of the pump whilst I've been testing it. And there we go. Now I'm going to turn the power to the boiler off, and I'm going to take a look at that capacitor in the pump. It's always safest to turn the main switch off that supplies the boiler with power. So I get my cross-headed screwdriver and I undo the cap on top of the pump, and that'll give me access to the capacitor and all the connections within the pump. So there we go. I'll now remove the cap, loosen off that screw and lift it away. I'm now going to pull out the capacitor, and it's this large white cylindrical thing here. They're not normally held in with any screws, possibly just a plastic clip. And there we go, that's the capacitor here, and you can see it has 2 electrical wires on it. Now I need to pull out this electrical plug so I can get to the 2 capacitor connections which go into the pump. So I give that a little wiggle and pull it upwards, and that little plug will then come out. I can then tuck that out the way, and you can see those electrical connections on the plug there, so that's why I definitely want to turn the power off. So now I can see the electrical connections which are going into the pump body. Now it's just a case of grabbing hold of the wires and giving them a bit of a wiggle and pulling them out of the pump. Now these wires don't really want to come out. That's not what the connector was designed to do. but if you give them a good old tug and a wiggle, then they will come out. And there we go, that's the first one out. Now it's just a case of doing exactly the same on the other wire. Again, this one is just as stubborn, it doesn't really want to come out. But there we go, that's that one out. So that's the old faulty capacitor removed now. So I've got another capacitor just here to replace it with. Now this isn't a new capacitor, it's a capacitor that I removed from another pump. Now these capacitors can be different sizes, so I just tend to keep them just in case, because they can come in really handy, if for no other reason than just proving the fault. Just before I show you how to refit the capacitor and test the boiler, let me quickly run through my introduction. My name is Mark Ballard and I've been a gas registered engineer for nearly 30 years. The aim of my channel is to help you with your central heating and your plumbing. If you find this video at all useful, then please give me that little bit of feedback by clicking on that thumbs up or the subscribe. You can ring on the bell if you want to receive a notification, and of course you can share the video with your friends. If you visit my website, I have categorized all my videos and products and parts that I recommend so you can easily find what you're looking for. And I'd like to say a really big thank you to everybody who's bought me a cup of coffee and left me a donation in my Toolbox fund. It's really appreciated and it does really help me to make more videos which will hopefully help you. Now it's just a case of pushing the wires back into the pump body. There's no plus or minus on them, so it doesn't matter which wire you use. I push the wire down, it is quite hard, and then I'm going to give it a pull to make sure that it's definitely firmly in the hole, which this one is. And then I do the same with the other wire, just get that one, make sure I put it in the correct hole. In this case it's the third hole along. So I just pop it in a hole and then grab hold of it and give it a good push down into the pump body. And there we go, you can see that's gone down, and again I give it a little tug just to make sure it's good and tight in that hole. Check the other one and that one's good as well. Okay, now it's just a case of popping the capacitor back into its little slot there like that, and obviously just tuck the wires back, and then I can take this electrical plug then plug that back into its hole like that. Again, just making sure those wires are all good. Carefully line that up with its holes, and then it's just a case of pushing it down into the correct position. And there we go, that's that plug back in, and now I'm ready to give it another test. So now I can put the cover back on and do up the screw. And there we go, the screw's now done up and the cover's on nice and tight. So now for the moment of truth. So I turn the boiler back on, got power on the display, there's a radiator symbol is there, let's press the minus button just to check pressure. I've got 1.5 and now the pump's going to come on. There we are, pump's running, and now it's jumped to 1.6, 1.7, which is great. So that means the pump started up on its own and the boiler is all running fine. And there you go, gas valve open and flame on. And there we go, that's all working fine now. Let's go and take a look at the burner, and through the little eye hole I can see that the burner is running nicely. Now I've just got to refit the cover, just hang it on the top, push it into place, make sure both the clips clip into position, and then do up the screw in the middle. And that's it, the job is all done. So initially when I first came to this job, I thought it was going to be a replacement pressure sensor because the customer had F75. And then I thought it was going to be the pump that needs to be replaced, but obviously it turns out I could just change the capacitor, and that saved this homeowner a whole lot of money with a really expensive new pump and obviously a return trip and the time taken to replace the pump. And if you're an engineer and you don't want to replace the capacitor, you could still do it as a temporary thing. So if it's freezing cold and the customer has no heating, you could get the pump working again and then come back with a new pump and fit the new pump for them. So it just buys you a little bit of time. And of course, if you want to know how I go about replacing a pressure sensor, pump or pressure vessel, I've made videos all about doing that. You can find a playlist above now, or you find the individual videos down in the description. Back to this boiler, and now just running the hot tap, just making sure everything is working fine. Now in this particular case, I've spoken to my customer and he is happy to keep this used capacitor in the boiler and just see how it goes, rather than spending £200 on a new pump and obviously replacement charge also. Now I have 3 different capacitors here which all came out of central heating pumps, and they've all got different numbers on the front of them. So which of these numbers are important? So the 2 numbers which are important on these motor run capacitors, where it says 2.5 and then a funny back to front U and then an F, and then it says plus or minus 5%. And then down on the bottom here, it also says 2,5 in big numbers. So you want to make sure that the capacitor that you are buying to replace your capacitor in your pump has the same number. Now the other important number is the voltage. Our central heating pump will be running at 230 volts. And we can see on this capacitor it says a maximum of 460 volts. What we don't want is that voltage to be lower. So where do you get one of these motor run capacitors? Well, if you just type into Google central heating pump capacitor, a whole load of those will come up, and then you can just pick the one that matches the capacitor that comes out of your pump. Right, that's about it then. So if you want to know how I go about changing a pump, you can click on the link just here. If you want to watch my playlist with all the videos in, I've made the little link just there. Of course, please give me a thumbs up, share me with your friends, subscribe, ring that bell, and as always, my toolbox friend. Bye for now, and I'll see you next time.